So, dear students, good day to all. Today we are going to discuss the circuit design for the sequential function such as A plus, B plus, A minus, B minus. I just going to do the simulation in fluid sim pneumatic software. Just open the fluid sim pneumatic software. Just open new page. On the left side of the library you have the various pneumatic components. The sequence for the circuit, we need to build a circuit for the sequences A plus, B plus, A minus, B minus. Okay, first you need to take the source element such as compressor, and then air service unit, then lubricated unit, connect them all. Next we require the actuator. So take the actuator out, and we require two cylinder. So this is A cylinder and this is B cylinder. A cylinder, B cylinder, B cylinder, B cylinder. So for activating double acting cylinder, we require either 4x2 direction control valve or else 3x2 direction control valve. So go to valves, take 4x2 direction control valve for each and every individual cylinder. Okay, so the arrow mark in the cylinder representing the cylinder cushioning. So this will be the double acting cylinder with cushioning effect on both extension side and retraction side. Okay, now we need to set the actuator for the direction control valve. Double click the direction control valve and you just set pilot operator. So this is the symbol for pilot operator. Using the fluidic energy we are going to change the position of the direction control valve, that is called pilot operator. Same thing also do here. Also mention the text for the DCV. DCV1, DCV1, you just copy and paste it here and change the name for DCV. And then the 4 port will be connected to the blind end of the cylinder. 2 port from the DCV need to be connected to the rod end of the cylinder. So same thing we need to do it with the B cylinder. Okay, Next you give the power source to one port of the DCV. Set the port 3 in the DCV to the vent. So go to properties. The terminator should be this is the open vent or close open vent, internal vent, external vent. So we choose external vent, give OK, go here, right click, properties, change it to external vent. The vent is used to release the air to the atmosphere. Okay. We need to determine the position of the cylinder. So for that we going to use mechanical sensor called limit switches. So for that limit switches you can use 3x2 direction control valve or else 2x2 direction control valve. So here itself I took 3x2 direction control valve. Then I rotate the 3x2 direction control valve. So first I need to set the actuator for the direction control valve. So on this side I choose roller, on this side I choose spring return mechanism. Okay, and just rotate it to 90 degree. So just mirror this limit switch, right click, mirror vertically. Then rotate it to 180 degree. You have the input in this direction, output in this direction. Just place the limit switch here. Similarly, you just copy the limit switch and paste it like here. Paste it like here. Okay. I need to specify the position of the cylinder and link with that limit switches. So these are the limit switches 1, 2, 3, 4. Okay. So right click the double acting cylinder, go to actuating label, specify the position of the cylinder. A minus will be 0, 0, A plus will be 100, that is maximum displacement from the cylinder we get 100 mm. So when you click the parameter tree tab, you can see the maximum stroke length of the cylinder is 100 mm. So I put maximum extension length will be 100 mm. Give OK. Can set the name label for B cylinder. B minus will be 0, 0. B plus will be 100, 100. And then link the position of the cylinder with the limit switch. Double click this roller. A minus. Double click this roller. A plus. Double click this roller. B minus. Double click this roller. B plus. Okay. So when the cylinder in retraction position, the rod of the cylinder will be pushes the lever. Therefore, the position of the DCV will be change here. Okay, change to this position. Okay, therefore we get the output from this limit switch. Okay, now what is the sequence? A plus B plus A minus B minus. So after B minus, what is the next sequence? A plus. Okay, so you get the output from this B minus limit switch. Okay, it need to be connect here to extend the E cylinder. Okay, so from B minus I receive the signal that need to be connected with the DC1 wall position 1 to extend the A cylinder. So after A cylinder extend, what will be happen? You get the output signal from here. Okay, so what is the next sequence? B cylinder need to extend. For extending the B cylinder, you need to give the pilot signal here. So from here I get the output signal from A plus. That pilot signal need to be given to the DCV2 wall position 1. Okay, after B cylinder extend, what is the next sequence? A cylinder need to be retract. So from the uh, B cylinder limit switch 2, I get the output signal here, that is control signal. That control signal need to be connected here to retract the A cylinder. A cylinder now retract. So after A cylinder retract, what is the next sequence need to be happen? B cylinder need to be retract. Okay, so connect it here. Okay, therefore the B cylinder will be retract. B cylinder will be retract here. We connect all the control signal from limit switch to DC, but we didn't connect the input signal to the limit switches. Just connect the input signal to the limit switches from the main power source. Okay, power signal for the limit switches. Okay, and set the BCD vent external vent. And then now simulate the circuit. So you need to put the state diagram here. Just only analyze the position. Just change another color to differentiate the B cylinder position. Okay, now start the simulation. You can see here A cylinder extend, next B cylinder extend, A minus happen, next B minus happen. Okay, from the graph you can understand A plus, B plus, A minus, B minus. Okay, A plus, plus, A minus and B minus. Okay, Thank you all. We will see in next sequence function.